Yeah. Good evening, students. Today, let us continue with the same chapter, that is motion in a straight line. In the last session, that is in the last class, we have learned about the concept of the distance and the displacement. And I have given the number of examples how to find the distance and the displacement for the given cases. We have considered an example for the circular motion. Yeah. Now today we'll talk about the concept of the speed and the velocity. Now let us consider a particle. Initially it is at the point A. Now the body is going to move to the final point. The body has moved to the final point. Let us say the final point is B. Now the total path length of this AB is 20 meter. What is the total path length of this? The total path length of this is 20 meter. Can you tell me this 20 meter is a distance or a displacement? It is a distance or a displacement? Yes, it is a distance. So what is the distance? 20 meter. Yeah. Now, whenever this particle is moving from A to B in this path, it has to take certain time, isn't it? Let us say it has taken a time of 10 seconds. So in how many seconds the particle has moved from A to B? The time is 10 seconds. Therefore, so for 10 seconds, the distance covered is 20 meter. For 10 seconds, the distance covered is 20 meter. Now, can you tell me what is the distance covered in 1 second? The distance covered in 1 second is, for 10 seconds, the distance is 20 meter. For 1 second, it has to cover 2 meter distance. So 2 meter is the distance traveled in 1 second. That will denote with per second. So what is this 2 meter per second? This is the distance traveled in 1 second. This distance traveled in 1 second is what we called as the speed. This is called as what? The speed. So speed is the distance traveled by the body in 1 second. So how mathematically this speed is going to be represented? Speed is measured as the distance traveled divided by the time taken. So the distance divided by the time taken is called as the distance. So distance by time is called as what? The speed. The speed is usually denoted with the symbol V. The distance is denoted with the symbol S. The time taken is T. So the velocity or the speed. Let us talk velocity later, students. So speed is nothing but the distance by time. Distance by time. So the distance by time is called as the speed. Can you tell me the SI unit of the speed? Yeah, SI unit of the speed is SI unit of the speed is meter per second. And also please remember it is a scalar quantity. It is a scalar quantity. What about the dimensional formula? Dimensional formula is m0 L1 T minus 1. So dimensional formula is m0 L1 T minus 1. This is the dimensional formula for the speed. So how do you define the speed? Speed is nothing but the distance traveled divided by the time taken. Now, we are going to talk about the speed in the different forms. One is uniform speed. Uniform speed. So what is uniform speed? So uniform speed is the one where it covers equal distances in equal intervals of time. If the particle covers equal distances in equal intervals of time, then we are going to say that the uniform speed. So uniform speed. Hello. Hello. Yes, madam. Okay, just a minute. I will check. Hey, please. Please. distance traveled in 1 second. Hello students, I hope now it is visible for you.
Yes, sir, it's visible.
Okay. Yeah. I think now I have explained with some example. I think you have not noticed that writing part. Let me explain briefly once again. Now look at this. The body has traveled from A to B. The body has traveled from A to B. It has covered the total path length of how much? 20 meter. The particle has covered a path length of how much? 20 meter. In how many seconds it has covered? 10 seconds. So in a 10 seconds, the body has covered a distance of 10 meter. So for 10 seconds, 20 meter. Can you tell me for 1 second, what is the distance covered? For 1 second, the distance covered is 2 meter per second. This is called as the speed. So speed is the distance traveled by the particle in 1 second. Wait, class can go. So in 1 second, the distance traveled is 2 meter per second. This is what we considered as the speed. So speed is the distance traveled by the particle in 1 second. So general formula for the speed is distance divided by the time. Speed is nothing but the distance divided by the time taken. Usually the speed is denoted by the symbol V, distance is denoted with S, and the time is denoted with T. So velocity is equal to the distance by time. So V is equal to S by T. Please remember, the speed is going to be measured in terms of meter per second, and it is a scalar quantity. The dimensional formula for the speed is m0 L1 t minus 1. And we are going to consider the speed in the different forms. One is called as the uniform speed. What is uniform speed? In the uniform speed, it is going to cover equal distance in equal intervals of time. So when the speed is said to be uniform, the speed is said to be uniform if it covers equal distances in equal intervals of time. If it covers equal distances in equal intervals of time, then it is said to be a uniform speed. Suppose if the particle is not covering equal distances in equal intervals of time, then it is said to be a non-uniform speed. Clear? So when the particle is said to be a uniform speed, the speed is said to be uniform speed if it covers equal distances in equal intervals of time. Suppose if this is not happening, then we are going to say it is a non-uniform speed. Yeah. The second thing is very, very important, Appa. That is called the average speed. Average speed. What is this average speed? Suppose, how to measure the average speed? Suppose if you consider the initial point, let us say A. Initial point is A. Now it reaches the final point B. Now for certain interval of time, the distance covered is x1 for a time of t1. Next it travel a certain distance x2. The time taken is t2. Then it travels a distance x3 in a time t3. Now for the equal intervals of time, we are getting the equal distances. Like for t1, the distance is x1. For the time t2, the distance is x2. For the time t3, the distance is x3. Now, how to calculate the average speed for this case? The average speed for this case is given by the total distance. Average speed is nothing but what? The total distance divided by the total time taken. Total distance divided by the total time taken. So what is the total distance? Total distance is x1 plus x2 plus x3 divided by the total time taken is t1 plus t2 plus t3. Yeah. So this is the basic definition for the average speed. So average speed is nothing but the total distance divided by the total time. Yeah. Now, let us consider the two different cases here. The two different cases I'm going to consider. Now, suppose if the body is moving with equal distance, body is covered with equal distance, body is covered with equal distance. Now, for example, this is the point A. Now there is a final point B. Now I'm going to consider the midpoint O. A to O, the distance is x. O to B, the distance is x. But for this first half of the distance, the time taken is t1. For the next half of the distance, the time taken is t2. The speed for the first half of the distance is v1. For the next half of the distance, the speed is v2. Then how to calculate the average speed for this case? It is nothing but the total distance divided by the total time, isn't it? Total distance, that is x plus x2x, by the total time t1 plus t2. Now, 2x by t1 can be taken as the distance by velocity. So x by v1 for t1. T1 is taking for a distance of x and for the velocity v1. So time is nothing but distance by velocity. So t1 is x by v1 plus T2 is x by V2. So what is the average speed for this case? If you take out x as common, we can cancel up with. So on simplification, you will get 2v1 v2 divided by v1 plus v2. So please remember the formula for the average speed. Average speed, this formula is valid only if the body is covering with the equal distances. If the body covers with the equal distances, what is the average speed formula? Average speed is given by the formula 2v1 v2 by v1 plus v2. Now, the second example, suppose if it covers equal intervals of time. Suppose if it is covering equal intervals of time, please remember the average speed is given by normal average, that is V1 plus V2 by 2. So what is the average speed if it covers equal intervals of time? If the body covers equal intervals of time, then the average speed is given by V1 plus V2 divided by 2. Please remember these two important formulas for your competitive level. Average speed is given by 2 times of V1, V2 by V1 plus V2. For equal intervals of time, the average speed value will be V1 plus V2. So this is the concept related to the average speed. Yeah. Look at this. Now I'm giving the definition. So for what I've explained, that is the concept of average speed. So you know that average speed is going to be calculated like the total distance traveled by the body to the total time taken to cover that particular distance. What is this ratio we called? This ratio we called as the average speed. So what's the symbol for the average speed? V bar. That is given by the average distance, the total distance, x1 plus x2 dot 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 divided by the total time t1 plus t2 dot dot dot. Yeah. Now I'm going to give the 3 examples for you students to understand in a better way of the concept of average speed. Now the very first example is the initial point is A. The initial point is A. Now it has covered certain distance and moved to the final point B. It has covered a certain distance, 2 meters in 2 seconds, then 4 meters, 3 seconds, then 2 meters, 1 second. So from initial point to the final point, the body has covered 3 different distances like 2 meters, 4 meters, 2 meters. The time interval will be like 2 seconds, 3 seconds, and 1 second. Can you find the average speed for this case? What's the basic definition for the average speed? Average speed is nothing but the total distance divided by the total time. Can you tell me the total distance? Can you tell me the total distance? The total distance is 2 plus 4 plus 2 divided by what is the total time? What is the total time? 2 plus 3 plus 1. So V bar is equal to 2 plus 4 plus 2 will be 8 by 3 plus 2 plus 1 will be 6. That is nothing but 4 by 3 meter per second. So what is the average speed? Average speed is given by 4 by 3 meter per second. So this is basic. Yeah. Now let us take up the second example. A is the initial point. B is the final point. There is a midpoint O. There is a midpoint O. Now, first half of the distance is covered by the particle with the speed 3 meter per second. This is x. X is the distance, equal distance. Then second half of the distance is covered with the speed 4 meter per second. First half of the distance is covered with the speed 3 meter per second. Second half is covered with the speed 4 meter per second. Can you find the average speed for this case? Don't go for the basic definition, students, because here they have not given the time interval. Look at the difference between the previous problem and this problem. In the previous problem, the time is given. In this, the time is not given. So, for equal distances, we have a formula, right? Shortcut formula. 2v1 v2 by v1 plus v2. So, what is the average speed formula? 2v1 v2 divided by v1 plus v2. So, average speed is given by 2 times of what is v1? V1 is 3 meter per second into V2. V2 is 4 meter per second. Whole thing divided by V1 plus V2, that is 3 plus 4. So average speed value will be equal to 2 into 3, 6. 6 into 4 will be 24. Divided by 3 plus 4 will be 7 meter per second. So what is the average speed? 24 by 7 meter per second. So please be very careful, students, how to find the average speed for the equal distances. For the equal distances, the average speed is given by the formula 2 times of V1 V2 divided by V1 plus V2. Got it? Yeah. Come to the third case. Come to the third case. Let us consider the initial point A, final point B. Now I'm going to mark one point O here. The time taken from A to O is t second. From O to B, the time taken is t second. So this is for equal interval of time I'm talking. First half of the time it is moving with the speed 4 meter per second. Second half of the time is moving with 6 meter per second. First half is moving with the speed 4 meter per second. Second half is moving with the speed 6 meter per second. How to find the average speed for this case? Average speed is nothing but, don't go with the total distance by total time, because there is a shortcut for this. For the equal interval of time, how to calculate the average speed? It is V1 plus V2 by 2. Average speed formula for equal intervals of time, that is V1 plus V2 by 2. So V bar is equal to 4 plus 6 by 2. That is 10 divided by 2. That is 5 meter per second. So what is the average speed for this case? 5 meter per second. Yeah. Take one more last example to analyze the concept of average speed. Now, I'm considering the particle A at A. Now it has moved to the final point B. Now, I'm going to consider O is the midpoint. O is the midpoint. And I'm going to consider one more point P here. This is taken same interval of time from A to P and P to O. A to P and P to O are equal intervals of time. O is the midpoint. O is the midpoint. Now, this is covered with 3 meter per second. This is covered with 5 meter per second. This is covered with 4 meter per second. A to P, what is the speed? 3 meter per second. P to O, what is the speed? 5 meter per second. For the next of, what is the speed? 4 meter per second. Now, I want what is the average speed for this complete journey? What is the speed for the complete journey? Yeah. For this, it is equal interval of time, right? For equal intervals of time, what is the average speed? 3 plus 5 divided by 2. V1 plus V2 by 2. That is 8 by 2, that is 4 meter per second. So for the first half of the distance, the speed is 4 meter per second. For the next half of the distance, the average speed is 4 meter per second. So how to take the average between these two? This 4 meter per second is for first half of the distance. This 4 meter per second is for the next half of the distance. So these two are taking place for equal distance. So for equal distance, average speed is given by the formula 2 times of V1, that is 4, into V2, that is 4, divided by V1 plus V2, that is 4 plus 4. So average speed is given by 2 into 4 into 4. How much? 2 into 4 into 4, 32, divided by 4 plus 4, that is 8. (32 by 8 will be 4 meter per second. So what is the average speed for the complete journey? The total complete journey, for the complete journey, the average speed is 4 meter per second. Yes, students, any doubt related to the average speed? I hope you got the concept of average speed. It is the basic definition, like the total distance divided by the total time. Yeah. Now, come to the concept of average velocity. Now, I will not waste much time to define this average velocity, because how you have defined the concept of the speed, how you have defined the concept of the speed, in the same way you have to talk about the displacement. Hello. 7 o'clock. So instead of talking about the distance, if I talk about the displacement, so displacement divided by the time taken is called the velocity. So speed is nothing but distance by time. Speed is nothing but the distance by time. Instead of taking the distance, if you take the displacement, displacement by time is called the velocity. So velocity is nothing but the displacement divided by the time taken. So only you have to replace what? You have to just replace the distance by displacement. Then the speed becomes the velocity. And the rest of the thing will be the same. Whatever the SI unit you are using, meter per second, that will be the same. But it is not a scalar quantity. Velocity is a vector quantity. But the dimensional formula still remains same. M0, L1, T minus 1. Velocity is vector quantity and SI unit is still meter per second. And the same formulas are going to valid for the average velocity. But instead of talking about the distance, you have to talk about the displacement. So how to take the average velocity definition then? Average velocity is nothing but the total displacement divided by what? The total time. The total time taken, the total displacement divided by the total time taken is called as the average velocity. Students, please keep it in mind. Only the difference is in the speed, we are considering the distance. In the case of velocity, we are discussing the concept of displacement. That is the change. Then you have to know the another important parameter, students, that is what we considered as instantaneous velocity. Now, in order to understand the meaning of this instantaneous velocity, let me consider one simple example. Now, there is a car is moving in the traffic. The car is moving in the traffic. Could you expect the car has to move with a uniform speed of 10 meters per second? All the time the car can keep the same speed 10 meters per second? No, not possible. Because if there is a sudden brake, if applied, the velocity decreases. If there is no brake at all, then it moves very fast, the speed will increases. So in the traffic, the car cannot keep the constant value. It keeps on changing. For every moment, it keeps on changing. So for every second, the velocity keeps on changing. So if you define what is the velocity at the given instant of time, at that moment, the velocity at that given instant of time is what we considered as the instantaneous velocity. So how do you define the instantaneous velocity? Instantaneous velocity is the velocity at that instant of time. Velocity at that instant of time. Velocity at that instant of time is what we call as the instantaneous velocity. So how do you define the instantaneous velocity? Instantaneous velocity is the one, it is the velocity at which it is going to measure at that instant of time. For the next moment, we don't know what happens to the velocity. Only when I'm talking about the instantaneous velocity, keep it in mind. Keep it in mind. I'm talking the velocity for that moment, only for that moment. That velocity, we call it as instantaneous velocity. And this instantaneous velocity is defined as dx by dt. Dx by dt means rate of change of distance x with respect to the time. Rate of change of distance with respect to time. That is what we considered as the instantaneous velocity. So what is instantaneous velocity? It is the velocity measured at a given instant of time. That velocity we will call it as an instantaneous velocity, that is dx by dt. So that is the mathematical form of the velocity. So if x is not constant, if x depends on the time, then velocity is given by v is equal to dx divided by dt. Yes, I hope you got the concept of instantaneous velocity, students. So it is the velocity at that moment. For the next minute, for the next second, not even minute, for the next second, we don't know what will be the velocity. It will change. So when I'm talking about the instantaneous velocity, please keep it in mind. That is the velocity for that moment, only for that moment. Got it? Yeah. So this is the concept of the instantaneous velocity. Yeah. Now, come to the next important concept, that is the acceleration. Acceleration. Now, whenever the particle is moving from A to B, let us say the particle is moving from A to B. Now, initially the velocity is v1. When it reaches the final point, let us say the velocity is v2. So clearly this tells, whenever the particle is moving, it is moving with a different velocities. The velocity keeps on changing. Let us say the time taken by the particle to come from A to B is t seconds. Then change in velocity with respect to time. You just find what is the change in velocity to the time. Change in velocity to the time. The change in the velocity with respect to the time is called acceleration A. So how do you define the acceleration? Acceleration is defined as the change in velocity to the time taken. The change in the velocity to the time taken is called as the acceleration. So how do you define the acceleration? Change in velocity to the time taken. Now, if v is the change in velocity and t is the time taken, then the acceleration is given by the formula velocity divided by the time. So acceleration is equal to velocity divided by the time. What is the SI unit? Yeah, look at the SI unit here. SI unit is meter per second squared. SI unit is what? Meter per second squared. This also can be written as m s minus 2. So what is the acceleration? Meter per second squared. M s minus 2. M s minus 2. Now, what about the dimensional formula for the acceleration? Dimensional formula for the acceleration is m0 L1 t minus 2. What's the dimensional formula for the acceleration? m0 L1 t minus 2. This is the dimensional formula for the acceleration. And remember, acceleration is a vector quantity. Acceleration is a vector quantity. Acceleration is a vector quantity. Suppose if the body is moving with a constant velocity, this is the point A, this is the point B. If the body is moving with a constant velocity, if the body is moving with a constant velocity, can you tell me what is the change in velocity? What is the change in velocity? Change in velocity is 0, isn't it? Because if the particle is moving with a constant velocity, there will be no change in the velocity. If there is no change in the velocity, can you tell me what will be the acceleration? Because how you define the acceleration? Acceleration is going to be defined as the change in velocity to the time taken. Since the change in velocity is 0, the acceleration is going to be 0. So acceleration is 0 if the body is moving with constant velocity. Such motion we call it as uniform motion. So what is uniform motion? Uniform motion is nothing but the particle moving with a constant velocity. For the constant velocity, for the uniform acceleration, the acceleration is equal to 0. So acceleration is equal to 0. Got it? Yeah. Similarly, for every moment, if the acceleration keeps on changing, for every moment, if the acceleration keeps on changing, then that acceleration, we call it as instantaneous acceleration. That instantaneous acceleration is given by which formula? It is rate of change of velocity, that is denoted with dv by dt. Acceleration is nothing but what? dv by dt. So instantaneous acceleration is the one where we are going to define the acceleration for that moment. For every second, the acceleration keeps on changing. For every second, the acceleration keeps on changing. For every second, the acceleration keeps on changing. Such an acceleration we are going to define with instantaneous acceleration. So instantaneous acceleration is nothing but dv by dt. dv by dt is the instantaneous acceleration. Then here also we are going to talk about the uniform acceleration. Uniform acceleration. When the acceleration is said to be uniform acceleration, suppose if the body is covering equal velocities in equal intervals of time, If the body is covering equal velocity in equal intervals of time, then it is said to be a uniform acceleration. It is said to be what? Uniform acceleration. Suppose if it is not covering equal velocity in equal intervals of time, then it is said to be a non-uniform acceleration. Non-uniform acceleration. Students, so far we have defined the important parameters like distance, displacement, speed, velocity, and acceleration. All these 5 parameters are going to be defined with respect to the time. Clear? All this distance, displacement, speed, velocity, all this going to be defined with respect to time. So time is the one which is independent variable, but the speed, displacement, velocity, acceleration, all these are going to depend on the time. How all these parameters are going to change with respect to time we are going to discuss. Clear? Yeah. Now, come to the another important type of acceleration, that is acceleration due to gravity. That is acceleration due to gravity. Before going to that, they have given the another important mathematical formula for the acceleration. You know that acceleration is defined as rate of change of velocity, that is a is equal to dv by dt. Now, you know that velocity is given by dx by dt. Dx by dt. So, acceleration can also be taken like this. dv by dx into dx by dt. What I'm doing here? Just I am multiplying and dividing by dx. Just I will multiply and divide by dx for dv by dt. So for dv by dt, I am multiplying and dividing by dx. If I do like this, a as it is, this dv by dx I will keep as it is into. What is this dx by dt? Dx by dt is nothing but the velocity v. So what is the acceleration? Acceleration is nothing but v into dv by dx. This is the acceleration. So what is acceleration? V into dv by dx. This is the other form of the acceleration. This is what they have defined. And no doubt, this is also very simple, right? Because a is nothing but dv by dt. Now I can substitute only for v, right? V can be taken as dx by dt. So d by dt of, in the place of v, I can take dx by dt, no? So a will become d squared x by dt into dt, that is dt squared. So acceleration is nothing but d squared x by dt squared. This is the another form of the acceleration. Okay? Yeah. Students, there is one more acceleration you can notice, that is negative acceleration. Suppose if the final speed is less than the initial speed, then you will come to know the acceleration as negative. That negative acceleration, we call it as a retardation. What is that negative acceleration called? Retardation. So please be careful. In the retardation, final velocity is less than the initial velocity. If initial velocity is more than the final velocity, if final velocity is more, then acceleration will be positive, no doubt. Acceleration will come to negative only if the final velocity is less than the initial velocity. That acceleration, we call it as negative acceleration. That is called the retardation, minus C. This is called retardation. And there is one more acceleration. I think you know that you have studied in the high school itself. That is acceleration due to gravity. Acceleration due to gravity. That is denoted with the symbol G. So how do you define the acceleration due to gravity G? Suppose if I say this is the Earth surface, from the Earth surface, if you have taken certain object of mass m, if you drop this object, what will happen? What will happen if I drop the object from certain height? Then this object will move downward with constant acceleration. The object will come down with a constant acceleration. This constant acceleration is called acceleration due to gravity, that is denoted by the symbol G. So what is acceleration due to gravity? Acceleration due to gravity is nothing but the constant acceleration in which the object is attracting towards the Earth. And this acceleration due to gravity value is 9.8 meter per second squared. 9.8 meter per second squared is the acceleration due to gravity. This is on the surface of the Earth. Remember that. But while using for the competitive, you can take the value of G as 10 meter per second squared only. So what is the value of G on the surface of the Earth? The value of G on the surface of the Earth is 9.8 meter per second squared. That is the acceleration due to gravity. So that is 10 meter per second square. Got it? So these are the different types of acceleration, that is retardation and acceleration due to gravity. I hope you got the today's concept, students. In the today's concept, we have explained the concept of the speed, velocity and uniform speed, average speed and acceleration. So these are the concepts related to the speed, velocity and the acceleration. Okay, students, I will stop at this stage. I hope you have understood the concepts of the today's session. So in the next session, we'll start the next concept in the next video. Thank you. Have a nice day.